several people coming in again, but we're going to get started. So again, this is Zach Parnell, Vice President of ITI. I want to welcome you all here to the Showcase webinar series. We have Matt Dina from FLUOR, he's a rigging engineer, on the line with us, and Mike Parnell, our host, as well. I just want to welcome you all, and if you're not familiar with the process here, you can insert questions throughout the webinar. On the right side, you have a little control panel. We encourage you to do that. I will be plugging those questions into a Word doc, and then we'll feed them to Matt after the presentation. We have several poll questions for you today as well that encourage interaction. And again, if you're not really familiar with our company, you haven't been on a webinar before, ITI, we're an education provider, world leader in crane and rigging training. We're in a bevy of different industry groups, much like FLUOR, as a leader in global EPC and construction. So we have a lot of folks, customers on here, and we have a lot of folks that we haven't done work for yet on the line as well. We just are excited to have you, and we work with some of the most prestigious and biggest companies in the world that want to improve their lifting and load handling operations. So if you've never been on a webinar, I encourage you to check out all the resources that you have now at your disposal. These are all the past presentations. You can actually go onto our website, and you'll have directions on how to do this after this webinar to look at all the past presentations, the videos of them, and also get the presentation files. Matt has been very, very generous to release this presentation to us, so this presentation will be on the website as well as the recording, and you'll have that URL in an email after the presentation. We also want to let you know next month we have a webinar called 9 Questions You Must Ask When Selecting a Crane Rigging Training Provider. And then on the right pane here, we have a lot of webinar training courses that we conduct. Most of our work is client site training or open enrollment courses at our training centers, but we also have instructor-led webinars coming up and throughout pretty much every month of the year. So I encourage you to check those out. Just to touch on Mike, our host, he's on every month, and he's our president and technical director of our company. He's got a lot of experience and knowledge. He currently sits as the volunteer. The ASME is a full volunteer board, and he's the vice chairman of the B30 committee, and he's also the P30 main committee chairman, which is a lift planning committee. So he's well respected in the industry, and probably a lot of you have heard him on here before, and he'll be chiming in with questions in the Q&A session and whatnot. Again, I explained we had Matt Dina. He's right here on the line. He's going to be taking over here after a poll question. Matt has had a great experience so far. He's a young engineer, but he's had a lot of accomplishments. He's worked for Bechtel, and now with FLUOR, he's a professional engineer. He's working on his MBA. I mean, he's a rock star, you guys. I'm excited to have you listen to him. They actually gave this presentation at the ACRP meeting in San Antonio earlier this year. So before I turn it over to Matt, however, we wanted to get an idea of what everyone had an opinion on, and we know we all have opinions, but it's regarding percentage of critical lifts in your organization. So you're going to see a poll question come up on the screen right now, and basically the question asks what percentage of critical lifts conducted in your organization utilize a lifting engineer. Okay, so feel free to comment there. I'm going to leave it open for about 5 seconds, and Matt is going to take over from here and begin the presentation. But this will give us a good idea of, again, these are critical lifts, not standard lifts in your organization. So your organization would have deemed them critical, and we're just curious how many of them involve a licensed engineer of some sort. I'll be closing the poll here in about 3 seconds. That was a long 5 seconds, but so I'll close it now. And it looks like we have pretty good results. About 61% of you said that between 0 and 25% actually use a licensed engineer. And this really probably depends or correlates to industry, Matt, I'm sure, as you can testify to, but about 20% did say 76% and above. So Matt, I'll hide these results, and I'm going to make you presenter here so that you can take over, okay?
Thank you, Zach. It's great to see ITI supporting the education of the industry. There's not a whole lot out there for rigging engineering, so that's one of the reasons we wanted to take part in this series and support the industry. As Zach mentioned, my background is as a civil engineer. I have bachelor's and master's degrees in civil engineering, and I've worked 4 years for FLUOR and previously worked for our competitor Bechtel. I've worked in 3 different countries and a couple different states throughout the United States. Also have my engineering license here in California. As Zach mentioned, I also want to give credit to my colleagues Brian Miller and Patrick Phillips for presenting this very similar presentation at the ACRP conference. I just adapted it slightly for today's presentation, so thank you for their help with this. So rigging engineering is kind of a specialized function, as I'm sure a lot of you are aware. Not every company has a dedicated rigging engineer on staff. Not every job really justifies it either. So there's some confusion even within my own company and other companies, kind of what a rigging engineer does, when you should get them involved, what sorts of information they need to do their job effectively. So those are some of the things I wanted to touch upon today. So just to give you a quick overview of what FLUOR is and what it's like to work in our environment. FLUOR is a large publicly traded engineering, procurement, and construction company. We're on the Fortune 500. We've just passed 100 years of experience as a company last year. So we're really happy with our success and would like to keep that going forward. We have about 40,000 employees throughout the world working on about 1,000 different projects annually. We have offices throughout the world. You can see most of the locations here. These are mostly permanent offices, and there's also offices to support project execution throughout the world. We serve various different industries, so this factors into our rigging engineering. In my position, I support different business lines, and part of the challenge is knowing what's important in those different business lines, knowing the terminology and the things that are unique to each business line. As you can see, we get involved in energy and chemicals, petrochemical projects, power projects. We have the global services division that helps do operation and maintenance and things like that. Also the industrial infrastructure division that gets involved in manufacturing, life sciences, mining and metals, roadways, bridge construction, things like that. We also have a division that does work for different government organizations. One of FLUOR's really things that we're proud of is our safety performance as a company. We're doing better than some of the other industry averages are, and that's something that we're really proud of. And this is really key when we're talking about rigging. As all of you know, that's the most important thing when we're talking about crane and rigging is to do the work safely. And really, I think that's the most important part of being a rigging engineer. Our goal is to perform the work efficiently and try and do it in a relatively low-cost manner, but I think our primary function is to support the safe operation for it and really be the technical resource to know what to look for and to develop and approve rigging plans to support safety. So today's discussion will go through a little bit on how a rigging engineer functions in a project and how that role changes throughout the different stages of a project. As I mentioned, FLUOR has a pretty broad scope in different projects. We get involved a lot of times in upfront in feed studies, doing the front-end engineering and doing feasibility studies for clients, all the way through doing the actual hands-on engineering design and procurement, and going through pre-construction, construction, project closeout. So throughout the different stages of the project, the role kind of varies a little bit, and it depends on what the project is. Some projects we just do engineering and procurement. Some projects we'll do engineering, procurement, construction management, or sometimes we'll do direct hire construction in conjunction with the engineering and design and procurement. Sometimes we'll just do construction. So really depends on what the project is, what is appropriate for that project. So ideally, we'd like rigging engineers to become involved early. This is kind of a central thing that we believe in FLUOR, is to get the construction organization, construction personnel involved in projects early and bring constructability focus to projects and make sure that what the design and procurement teams are doing is really constructible, and trying to think of things, pre-plan things. One of our central tenets of safety is to pre-plan our work and not let it come down to the last minute before you're trying to scramble to do the work in the field. So as early as we can get bringing engineers and other construction professionals involved in the project, that's really what we would like to do. Just a reminder, if you have any questions, you can type them in to your panel on your screen, and Zach will compile them and we'll answer them at a later point. So starting off with conceptual planning, early on in the project, sometimes we get involved with defining what the rigging requirements are. There's many, as we work in many different industries and many different countries throughout the world, many different clients, sometimes it's a challenge to get alignment on what the rules are for rigging standards, specifications, which safety standards we will follow, which industry standards, which ASME codes will apply, things like that, which client specifications. Sometimes clients even have, a lot of times will have their own lifting policy, and sometimes it'll differ even for the specific project site that it's on. So one of the things that's really important early on is to define those requirements, define the standards, the specifications that we will follow, and get agreement and have everyone sign off on those things. So we also get involved in some of our projects involve heavy haul, transporting modules like you'll see in the picture there. FLUOR has a strong modularization program that we try to, on projects where it's appropriate, we try to build modules and get the work done off-site in an area that has more resources available to be more cost-effective or to support the schedule of the project. So a lot of times that involves transporting really large loads. So in conjunction with our logistics experts, our rigging engineers will get involved with doing some of the route studies, looking at roads, bridges, obstructions, getting involved in looking at the permits. A lot of times FLUOR doesn't do the actual heavy haul itself. It'll subcontract this out to a heavy haul rigging company, but the rigging engineers help get involved and make sure that all the requirements are met and that all the parties are talking to one another and understand what needs to be done. Also get involved early on in the project, looking at what sorts of cranes, what sort of hardware will be required for the project, defining standards, what will we have to do a load test on site, things like that, coming to an agreement on what sorts of lift kind of classifications will be used on the project. As I mentioned, we help support the development of the construction execution strategy. FLUOR has many different project types, a lot of different methods for executing the construction. As I mentioned, we have a modularization program that is really strong, that we're trying to grow that even more. So we have modularization experts within the company that work together with construction and engineering to work on those requirements, and us as rigging engineers will get involved to make sure that if we need to handle those modules by heavy haul equipment or a crane to lift it, that it's feasible, that we're looking at the right sorts of things for that. We also help determine what sort of crane will be needed for the projects. They get involved with doing a site walk down, getting boots on the ground to look at what sorts of obstructions, what sorts of transport routes to get equipment in and out, what sorts of challenges like that we have to deal with. As I mentioned, we many times work in partnership with a heavy haul, heavy lift contractor to actually provide the equipment. FLUOR doesn't own a whole lot of its own equipment. We tend to rent it a lot of times, so we work along with the contractors that will supply the equipment and make sure that it's feasible, what sorts of availability, look at the cost of it. Sometimes these items can be really long lead time. This photograph here is from a project I worked on, a bridge project, where this crane was actually custom fabricated for the project. So the duration of custom fabricating a piece of equipment like this is on the order of years. This particular crane was built both in the United States and in Asia. So there's a lot of logistical challenges to it and a lot of work involved just to come up with the equipment in certain projects like this. You can also see the yellow lifting frame connecting onto the bridge section was custom fabricated for this project with some adjustability in it. So a lot of work went in up front way before we mobilized to the field to start lifting these components. A lot of work had to go into building this crane. So not every project is going to need its own crane custom designed for it. That's kind of an exception. But these are the things that we tend to look at early on the project. How will we go about constructing it? We also get involved in development of the site and unit plot plan. A lot of times with refinery projects or power plants, things like that, the real estate can get really crowded, and we really have to be careful with how we build the project, not to build ourselves into a corner, and to look at things if we need to hold a foundation, if we need to hold out steel in a certain area to support a transport route or to support crane access. We need vessel dress out areas, lay down areas where we can stage components where the crane or the trailers can reach it to pick it up. Also identifying any utilities that might be in the way and coming up with a plan to address that. We also look at alternative lifting solutions in some cases. Not every project calls for this, but certain projects you can be more cost effective and more safe by looking at alternative solutions, possibly jack and slide systems, monorails, strand jacks, things like that. Again, this photograph is from a bridge project where we custom fabricated all the red steel you see as a temporary erection tower to build the permanent tower behind it. And you see, I forget the numbers on the lift. I think it's roughly about a 600-ton lift being performed there by 2 strand jacks. And those strand jacks travel on top of a jack and slide system on top that can position the saddle that's being lifted. So a lot of work went into that project up front to design the erection system just to be able to place the components. It would be very difficult to find a crane to be able to do this, so the alternative system was really the best way to go in this case.
Hey Matt, if I can interject there, we had a great poll question for conceptual planning. So everybody, we're going to launch this poll, and the question basically is regarding how much lead time are you putting in, or on average how much lead time do you put into planning critical lifts. So it might be a critical lift in your industry might not be that critical or not that difficult to plan, meaning 1 day or 1 week. Some industries might be 6 months or 3 months. So we'd love to hear your feedback on this. Matt, for that strand jack lift, what was your lead time planning for that tower?
I'm not sure the exact lead time. I came into the project after a lot of that work was done, but I'd say it's on the order of years. There's a lot of work that went into designing that lift tower, a lot of different subcontractors and consultants that helped us design it and procure it, and a lot of the steel was shipped from foreign countries, so there's a lot of lead time involved in just getting the steel there.
Sure. Well, just as you're saying, it's not just a lift you're making. It's a full. It's not like a maintenance activity. I think that's a big differentiator. And everyone, I'll leave this poll open for another 5 seconds or so. But the differentiation is for FLUOR, you guys are conducting mostly maintenance activities, or I'm sorry, mostly construction activities in new build. A maintenance piece, when you're replacing something, that's all the activity might be that you're doing, right? So you're just making one lift or a few lifts. In this scenario, you probably had to consider the entire, in the construction phase, consider the entire, all the lifts you're going to be making throughout it. So I think that's a big difference probably between maintenance personnel and then construction, right?
Sure, and FLUOR does get involved in maintenance projects. We'll get involved helping out with power plants going through a shutdown, replacing old equipment. Sometimes we'll come in and we'll have to custom design a monorail or something to get in and to move out some piping or some other components. So
Sure.
we do get involved in projects like that also. So yeah, whatever is appropriate to the project, there's a lot of different scope depending on which project you're looking at. It's one of the exciting things of being in this position and seeing different projects at different stages and getting to see a lot of different variation there.
Yeah, well, very good. Well, I'm sure you all saw the poll results there. We'll ask one more poll question at the very end, Matt, so go ahead and take it away, buddy.
Okay. So getting into the detailed engineering design and procurement stage, the stage can be pretty long. This can go on for years on some of our projects. As I mentioned, we get involved with helping develop the site unit plot plan. This keeps getting involved over the life of the project. As other experts come in, our process engineers, our plant layout experts, things like that. We work in partnership with them to try and look at all these issues. We also provide rigging input into the structural design and mechanical equipment. We work together with our mechanical engineers, our structural engineers, and make sure that the things that we're designing are constructible, whether we'll need any specialized hardware to erect it or to align it. Another picture here from the same project shows a custom spreader beam that was fabricated for lifting the tower shaft segments there. As you can see, the size of it is really big. I believe those are 600-ton shackles, so really not easy to move them, and just getting it hooked up to the piece being picked is really quite a challenge. So a lot of work went into looking at those sorts of challenges and looking at providing the safety for the men hooking up the equipment. So we get involved with helping look at cost savings measures, if there's alternative solutions that we could use. Also get involved in refining a modularization plan. Again, we're looking at procuring long lead items during this phase. We have to custom fabricate a crane, or if there's a crane that doesn't have a whole lot of availability or some sort of specialty rigging hardware, we're trying to get involved with the project and have them start thinking about these things, these long lead item equipment, to see if they'll be available, if the cost will meet project requirements, things like that. Also get involved in helping refine the heavy haul transport requirements. Again, looking at the equipment needs and availability. Coordinating selection and approval of the haul route with our contractor that will be performing the work. Also looking at any temporary steel needed for hauling, any steel needed to resist dynamic forces or to get the loads onto the trailers, things like that. There's a couple pictures of some of our typical working environments. On your left, you see a petrochemical project in the United States. We can see that can get pretty congested, so we start to look at things like crane access, interferences, swing radius, boom clearance. On your right is another petrochemical project, coker construction, again in the United States. So some of the things we get involved in is doing the detailed calculations for some of the lifts. As I mentioned, my background is as a civil engineer. I think most rigging engineers in my experience either have a civil engineering or mechanical engineering background. So these calculations are just an example of looking at the loads as you tail a vessel with two different cranes as the angle changes, calculating the forces on each end of the vessel. Again, another example of a calculation looking at the stresses on the base ring for tailing a vessel, and also looking at the bolted flange lug. Here's another example of another lifting lug design. So some of the things we look at in this stage in the engineering, design, and procurement, working together with our mechanical engineers and other experts in the company, again, trying to make sure that what we're designing is constructible and will be feasible once we get to the field, trying to catch any problems before they show up in the field and trying to catch them at an early stage before it becomes really costly to fix them. So on the left, you can see, kind of in the center of the picture, you can see a lug. And the problem in this case, the lug didn't have adequate clearance to hook up a shackle to allow lifting it. So that's obviously a problem that you wouldn't want to find in the field. You'd like to fix that in the design stage. On the right, you can see a vessel with trunnions on it. The problem in this case was the trunnions were delivered, the vessel was delivered on site in the wrong orientation, so the trunnion was not in a very feasible location to pick it up in this case. So also getting involved in the procurement of logistics personnel and trying to ensure these things are looked at our contracts and our document review to ensure all these sorts of concerns are picked up and communicated to all parties before these items show up in the field. So one of the things we'll look at on some projects, this is probably more typical for a petrochemical project, looking at dressed columns, larger vessels that have external platforms or ladders, things like that added onto it. Just looking at these sorts of protrusions off the vessel to see how it will affect our rigging and transport. So if we're transporting a vessel with these sorts of platforms on them or things, ladders or anything, we need to ensure that the shipping saddles are tall enough to clear these obstructions. We need to ensure that the saddles are wide enough to support the stability of transporting the load on the trailer. Ensure that the shipping saddles are attached to the column, again, to ensure transport stability. Looking at things like clearing insulation and also ensuring that the saddles are modeled in our 3D model. A lot of our more complicated projects use a 3D model to look at all sorts of obstructions like this and to ensure the geometry works digitally before we get out into the field. So ensuring that all these components are thought of up front in the design stage and modeled and checking geometry and clearances, things like that, is something that we'll get involved in. Here's another example of a platform. This time it's closer to the top of the vessel. So if we're lifting the vessel from the top, we need to ensure that the platform will clear the lifting logs, clear the slings, things like that, and that we have adequate access for the riggers to get up and access those components to put on or take off the shackles or slings or whatever your rigging hardware is. Just ensuring that the work can be done and that there's no major obstructions. We'll help look at the tailing lugs on vessels, help our mechanical engineers and other experts work together with our vendors that are fabricating these vessels to provide a tailing lug. Again, going back to like the spreadsheet I showed and the calculation for looking at the load transfer when you're tailing a vessel like this, ensuring that you have a smooth load transfer from the tail to the head crane, designing the lug for strength, ensuring it meets any required specifications if you're using ASME codes to design these lugs or things like that. Checking the base ring stress, again, like the example I showed earlier. And again, checking that all the clearances are there. If there's platforms that hang out, you don't want the load block or the slings coming into contact with the platform and potentially damaging it. So moving on into pre-construction. Again, these are a lot of times very iterative, and a lot of our projects are on the order of years in planning and before we get to the field. So coming up with our subcontractors and doing technical evaluations on them, assisting with final selection, and trying to get the best value for our vendors that help us out with these things. Also finalizing crane plot layouts. Again, look at the plot plan, both in plan and elevation or in the 3D model, making sure that there's room for bringing the crane on site, assembling it, booming up, things like that. Looking at ground bearing requirements, working together with the soils engineers, the soils reports, geotechnical experts, looking at if we need to establish crane mats or more sophisticated ground bearing systems. So again, here's an example of looking at the plot plan. I know this picture is pretty hard to see, but basically we're just looking at areas of where we might need to hold out foundation or hold some steel for later erection after the crane or the rigging equipment has completed its job. Just working together with our other experts on site to try to look at the schedule and look at the sequence of construction, things like that. So we will help projects work on procuring rigging hardware, providing general site rigging, common sling shackle spreaders, or if there's a particular one that's needed for a certain lift. A lot of times we just have a rigging loft with common hardware that the personnel can use. We may have a case where you need some really specialized equipment, so we try to identify these up front and get them prepared and work with our procurement people to ensure that they show up at the right time and that the right materials are specified and inspected, things like that. Then we get involved in looking at potential critical lifts. FLUOR has kind of a graded system for classifying lifts depending on complexity and weight, things like that. What kind of requirements, what sorts of reviews are required, what sorts of documentation. So we start working together with the construction team to classify these lifts and kind of come up with a list and look at the sequence of how these lifts will go together and what sorts of review, what kind of timeline we need to put it together, what sorts of equipment, things like that. And then we'll start generating lifting and rigging plans. Again, this depends on the scope on the project. Some projects, FLUOR does its own construction work, and we will produce these rigging plans internally. Other projects, we will be working in more of a construction management environment where we're overseeing other contractors doing the work. So depending on the project scope and execution strategy, whether or not we do these lift plans internally or if we review and approve and provide guidance for our contractors that are doing the work. Again, working with the project or the contractors to support selection of cranes and other lifting equipment, and then supporting mobilization of those cranes onto site. And moving into construction, this is my personal favorite stage of things. It's great to finally get on the ground and see the work being done, the work of the riggers, the iron workers, the other tradesmen doing the work is my personal favorite part of it. So again, as I mentioned, depending on whether we're doing the work ourselves in direct hire construction, or if we have other contractors doing the work, or a lot of times we'll have heavy haul, heavy lift subcontractors that have the specialized equipment that we don't have long term. Getting them involved in the project and helping ensure that everyone is communicating and looking at the right sorts of things, looking at any kind of permits for heavy haul or permits for crane erection, things like that. Again, looking at the haul route, make sure it's prepared properly, obstructions are addressed, things like that. Looking at the crane assembly, disassembly, supporting the safe execution of that work, supporting that there's enough lay-down room for things like this, just making sure that everyone's talking and looking at these sorts of concerns. And again, looking at the crane location verification, these are ongoing concerns as cranes move around on site, and we may change on and off equipment throughout the life of the project. You may have a certain crane that's needed for a couple lifts and then it moves out. So these are constant concerns on the construction site. I'm sure all of you know that things change daily and hourly on the construction site. So working together with the team to try and make sure that these things are looked at and nothing gets overlooked. We don't always have a rigging engineer per se on site on the project full time. Depending on the scope and the complexity of the project, we may have other field engineers or rigging superintendents or other personnel kind of looking at the day-to-day operations. Sometimes we'll bring in a rigging engineer for a particular complex lift, and in other cases, projects will have enough scope that we will place someone full-time, a rigging engineer, to look at these sorts of things throughout the life of the project. So here's an example of a heavy haul transport plan with a SPMT trailer. Again, I know this is hard to read, but basically we're just looking at how the load sits on the trailer, looking at tie-down equipment, tie-down forces, looking at ground loading, looking at stability, ensuring the saddles support the load properly, things like that. Other items we will get involved in from time to time, designing temporary support and guying systems. Again, not every project needs large guying systems, but in certain projects we will get involved in helping look at design and construct guying systems to ensure that structures are stable until they're completed. Again, assisting with procurement of the rigging hardware. We normally have procurement professionals that deal with this as their daily job, but we will get involved with helping look at that the right specifications are included in the procurement documents, that the right sorts of things are being bought and inspected and brought on site. And sometimes we will get involved with providing rigging and lift plan training to the craft personnel or to other non-manual other engineers on site, just making sure that everyone is talking and looking at the right sorts of things and that everyone's training is up to the standard that we'd like for the project. Again, trying to support safety here and just make sure that everyone is aware of all the concerns. A couple other pictures of some fairly typical FLUOR projects. On the left, you can see another energy and chemicals project, the module being transported off of a ship, being lifted by the ship's own crane gear and being transported onto, I believe that's a barge in this case. And on the right, you see another petrochemical project lifting a vessel, tailing it with 2 cranes in this case. So you can see some of the concerns with looking at that you're not overloading the tail lug, the base spring stresses on the tailing end of the vessel. You can see the the spreader involved in picking the tail end of that, the head end of that vessel. In some projects, we will look at supporting pre-assemblies on site. A lot of times on power projects, there's very large ductwork pieces that go into the construction. Sometimes these are delivered on site in fairly large pieces, pre-assembled off site. Sometimes they're brought on site and we add additional pieces onto it on site, and then the means of transporting these on site and then erecting them. Sometimes these components can be a challenge to deal with because of their size and the lifting points, things like that. Another common thing to look at is with these pre-assemblies to make sure that that the documentation is there. That I've seen cases where the documents will say the weight of the piece in pounds when really it's the weight in kilograms, and the units have been transposed, things like that. So just making sure that the documentation is there. We add pieces onto it in the field from what the documentation is, making sure that that weight of that additional piece is taken into account with the lift planning, looking if that affects the center of gravity. Oftentimes these can be really challenging, knowing which particular section of the overall structure that you're lifting, and trying to make sure that the documentation you use for planning the lift matches what's actually going to be performed in the field. In the right picture, it's a little bit hard to see, but you can see some power lines in the foreground of the picture. So again, these are things that we help projects look at, ensure that there'll be clearance around these power lines. If we have to have permits involved to shut down the lines or encroachment upon the lines, just making sure that we're working safely around any obstructions, things like that, and that everyone's looking at the right sorts of concerns and keeping aware of these things as we do the work. So again, helping develop and issue the rigging and lifting plans. This is really kind of the heart and soul of being a rigging engineer. As I mentioned before, you have to come to agreement on what standards will be involved in developing these lifting plans, whether there's local OSHA in the United States, certain states have their own OSHA. When you're working in the mining industry, there's MSHA rules to look at also. So making sure that we're looking at the right sorts of regulations, safety regulations. If we're working in a foreign country, making sure that we're aware of their requirements, things like that. So again, we help the project and the other engineers within FLUOR and help the personnel, the craft doing the work, make sure that we're looking at the right sorts of rigging hardware, doing the technical verification on these, that they have the right strength, right sorts of documentation to back them up, if there's a load test required, looking at those sorts of things. And again, looking at the plot layout, making sure that it's going to be constructible, and as the construction site progresses and changes daily, making sure that we still have room to maneuver and to do the erection of the particular components. And again, looking at the method for delivery of the equipment, trying to see how we're going to bring that equipment on site, how you will deliver it to the crane or whatever hardware you're using to erect it, just making sure that those concerns are looked at and planned for. And again, as I mentioned, working with the field to ensure that the piece before we actually pick it, that the dimensions, the weight, the center of gravity, the lifting attachments, the lifting lugs, things like that, matched what we expected from the documentation from our early planning, making sure that those things are actually fabricated and delivered as we expected them to be, and dealing with any last minute changes that might come up if there's any discrepancies in these items. So again, looking at the ground bearing requirements, if we need to provide mats for the crane, if there's certain areas that we need to avoid. Looking at potential interferences, as I mentioned, you might have power lines in the way. Adjacent to a lift is a common concern. If you have existing plant equipment in the way, we'll be working in an operating plant environment. If we have to lift over a live process area, those lifts typically become very critical lifts that get a lot of scrutiny. So looking at those sorts of things, where our load path will be in swinging the crane, swinging the load over things, making sure that those load paths are clear and that we have adequate barricades to keep personnel out, and also looking at potential interferences. Again, looking at underground utilities, excavations, manholes, things like that. A lot of times these excavations are going on in parallel with our crane work, so keeping track of which excavations are where, ensuring that there's adequate backfill and compaction, things like that. And then being the technical resources for the craft personnel and the other engineers and the other managers on site, ensuring that they're looking at the load charts for cranes and other rigging equipment, looking at the charts properly. Sometimes this can be difficult. There's not a whole lot of standardization of load charts among the different manufacturers. So we try to be the technical resource and keep up with how each manufacturer lists their requirements that you need to follow, and making sure that everyone is aware of the fine print in the load charts and things like that, and looking at the right sorts of concerns. Again, looking at the load ratings for equipment, making sure that those are followed on site. We'd like to keep our crane percentage utilization at an appropriate level. Some projects, depending on requirements and geometry, things like that, we really have to go out to a high percentage of the crane chart. So those lifts tend to get more scrutiny and more concern, and make it a little bit more detailed in the planning in those cases. And again, looking at ensuring that the site has adequate room for the crane to work, tail swing, room for the crane to boom up, boom down. If there's severe weather that comes in and the crane needs to boom down in a quick manner, ensuring that those sorts of concerns that are addressed. And again, being the kind of the technical expert and possibly conversing with the manufacturer directly to ensure that we understand the limitations of the equipment as it's designed and the operational restrictions, things like that. Just making sure that the work is being done in alignment with those requirements. There's so many different manufacturers, different equipment nowadays that it becomes a challenge to keep on top of knowing what the limits of your particular equipment are and making sure that we're not exceeding them. You know, we have a lot of lifting aids nowadays with computers on cranes and things, but we really need to be cognizant of all those limitations on the equipment and make sure that they're followed and make sure that they're communicated to the people doing the work and the superintendents, the other safety representatives on site. FLUOR has really strong safety representative program on sites. We believe that everyone is responsible for safety on site. It's not just the safety person's job. Everyone should be aware of this. So a lot of times those personnel may not have the detailed technical knowledge of the rigging equipment being used. So ensuring that those personnel are aware of those sorts of concerns also, and kind of giving another set of eyes to make sure that nothing gets overlooked or gets missed. Here's an example of a rigging drawing. Again, I know these are very hard to read, but from the top left you can see a plot plan looking at the plan view, looking at the crane radius, looking at where the crane would be sitting for utilities and ways, things like that. We have our general notes. There's an erection procedure, a narrative of the steps that should be gone through in performing the lift. The top right, you can see kind of a tabulation of the lifting crane data for the primary crane and the tail crane. Some data about the vessel being lifted. In the center, you can see the elevation view, looking at the radius of the lift, looking at the boom length, looking at the height of the lift, things like checking the tube lock distance. And on the right side, you can see two different views of the rigging hookup, specifying the equipment and the geometry of how that will work, the spreader beam, shackles, slings, things like that. May call out the particular load block that's required on the crane. Here's another example of another rigging drawing. This one's a little more focused on the rigging hookup. Again, just calling out the equipment that's required, some of the geometry, and some of the notes that are important to keep in mind in this. So again, as we're working in construction in the fields, helping oversee the lifting operations, generally the rigging engineer isn't the one actually directing the lift. Usually there'll be a superintendent or a foreman directing the lift. So we work in conjunction with them. As I mentioned, we may not always be there for every particular lift as a dedicated rigging engineer. At certain lifts, we will be out on site. For certain projects, we'll be there throughout the duration of the project. We're just working with the field personnel to make sure that the lifting and rigging plans are approved by the proper people, the right documentation is involved in the field. Sometimes it can be a challenge to make sure that the most current documentation is being used. Any last minute changes that may come up with the equipment or the crane setup, if anything comes up last minute, kind of overseeing that, making sure it's approved as appropriate. We need to get client approval of those actions, approval by the safety representatives on the project or the project manager, things like that. And then assisting in inspection of the actual crane setup, the last check you do before you perform the lift, making sure that all the hardware matches what was specified, that there's no obvious signs of damage in the equipment, maybe any cracks in a shackle, things like that. Just making sure that everything is as expected to be and it's hooked up properly and matches the drawings and what has been approved. Again, oversight of the lifting operations. We get involved in pre-lift meetings, again, making sure that everyone is communicating and that the plan is understood by everyone involved. Communication can be a challenge on certain projects, different languages, different experience levels involved, many different people involved in certain lifts. So making sure that everyone is communicating and understands the terminology and the sequence of things that will happen, what particular equipment will be used, what the authority is for performing the lift, when we need to stop, if the wind picks up or other environmental conditions. We've had situations where the boom of your crane gets iced up with a thick layer of ice and adds to the load on the crane when you may have to stop the lift and wait for the weather to be more favorable. Just making sure that everyone is aware of those particular limitations of a lift. These limitations can be very specific to the particular crane involved, maybe specific to the site. So making sure that the personnel performing the lift and the managers overseeing the lift, making sure that everyone is aware of what parameters the lift can take place in and what parameters we need to stop and hold off and reevaluate things. Again, facilitating approval of lift plans is depending upon the particular site or project policy, whether we're developing those plans internally or if we're we as FLUOR are approving and reviewing another contractor's lifting plans that they have developed, just making sure that those approvals are all in place and that the appropriate parties have signed off on it. Monitoring the lift for other concerns, any settlement of the collar tracks, picking up an outrigger, things like that you really want to watch out for. You know, we're not the only ones qualified to look at these sorts of things, but just making sure that people are looking at these things and giving another set of eyes to make sure that all those sorts of concerns are being addressed. And again, dealing with any last-minute changes to plans. As we all know, things can change once you get onto the field, and the situation may change. Something unplanned came up, the wrong equipment was delivered, whatever the case may be, looking at those sorts of changes and seeing if we can still perform the lift safely and what sorts of approvals or documentation changes are needed to support those. Some other concerns also, as I mentioned, verifying the center of gravity and the stability of the load is as you expected, verifying the weights and checking units on the weights, making sure that the softeners are used as appropriate to protect slings or other hardware, making sure the equipment is being used and even being stored in the appropriate conditions, helping monitor communications, making sure that, again, that parties are communicating effectively, whether we're using hand signals or radios or whatever system is being used for communications, just making sure that the lift goes smoothly and that everyone understands their role and is communicating to the other people involved in it. And again, as ring engineers, just kind of being the technical resource for anyone in the field to come to with questions about the equipment limitations or the equipment capacity or the particular hardware that we're using, ensuring that the right slings are used, things like that. You know, industry has new equipment constantly being developed, new sorts of shackle designs or frame designs that may be new to the personnel performing the lift. So making sure that technically we're kind of the experts that people can come to and ask questions and make sure that everyone is comfortable and understands how that equipment works and what its limitations and capacity is. Again, here's a couple pictures of, again, the bridge project I worked on, the custom fabricated barge crane, and this was actually the lifting frame you see above the bridge deck piece. That lifting frame, there's a couple different lifting frames used on that project, all custom fabricated for that project, long lead items fabricated outside the United States and delivered here. Ensuring that the load test is performed on that equipment, ensuring that it's designed to the right safety factors, things like that. And on the right, you see another energy and chemicals type project. Again, lifting, tailing a vessel up from horizontal into vertical. You can see the external platforms that I mentioned previously, helping support the safe operation of those sorts of lifts. And then moving on to the final stage of the project closeout. We may not be on site on the project at this point. We may have demobilized from the project if we were there in the field, but supporting project closeout, making sure that any documentation is properly recorded in the project files, helping close out subcontracts and performing evaluations on how our suppliers and partners performed, and any things that were learned from the project, ensure that those are captured and passed on to future projects, and doing debriefing reports. And with that, I think that concludes what I wanted to present, and Zach, we can open it up to questions now.
Yes, perfect. Great job, Matt. Before we do that, let me, I'm going to launch one last poll question, everyone. So let's do that right now. we want to get your perspective on this after understanding all the complex lifting activities that are happening. Especially, I loved all the pictures, Matt, you guys had in various industry groups. But it's basically which industries offer the most complex lifting activities. And you can select more than one, so give it some thought. We'd like to hear your opinion. And Matt, while we're doing that, I'll read you the first question, and maybe you can answer. And then everyone, if you're waiting, feel free to put in any questions you have. We have time to go over a few of them. So Matt, basically, first question is, do you feel the need for a PE to stamp all lifts? If not, when? Well, first of all, that's the first question. Then if not, when do you feel that a PE needs to stamp a lift? Matt, did we lose you?
Oh, no, just turned off mute, sorry. So the question is, when is it necessary for a professional engineer to get involved in approving a lift?
Well, it's almost an opinion question, and you can broaden it if you like, but do you feel the need for a PE to stamp every lift? I mean, that's kind of a universal, but I guess the major question is, when do you feel a PE needs to be involved with a critical lift?
Well, my personal opinion is I don't think a professional engineer is necessary for every lift. This may depend upon the particular requirements of the project and which jurisdiction you're working in, what your client would like, things like that. So I don't believe a professional engineer is required for every lift, but someone with adequate experience and adequate training should really be involved with every lift. Certain lifts, the foreman or the riggers in the field have the adequate experience and the knowledge to go ahead and perform those safely. Other lifts are very complicated. You may have a lift where you're lifting over live process equipment or live electric lines, something like that. Really demand a little bit higher level of technical knowledge, or again, in cases where if you have to custom fabricate components for the lift, then I think you need to start looking at having an engineer design it. It may not be someone licensed engineer depending upon the particular requirements of the project. I think you just need to focus on having people with the right knowledge and the right experience review it as appropriate. So there are a number of cases where I think you need someone with an engineering background that can understand the stress and the strain to the components and making sure that things aren't overloaded. So really just looking at if you're operating within the allowable parameters that the manufacturer has provided, if you're following the load charts of the cranes and following the allowable capacities by your shackle manufacturer, things like that, you may not need an engineer, but if you're getting outside those limits and designing something custom and really unique, then I think you need to look at having an engineer become involved.
Okay, well, thanks for that answer. I think that makes perfect sense, Matt. It's all relative to the situation, right? So I appreciate it. Another good question that came in, how often do you run across your subcontractors that have their own rigging engineers?
Let's say it's fairly common. It depends on the kind of project, what sort of contractor we're getting involved in. Some of of course, the major crane and rigging companies often have that. Sometimes some of the other steel erection companies may not have someone with a rigging engineer title, but they probably have some engineers on staff, whether that's a field engineer or whatever their particular title is. I think it's fairly common for our contractors to have someone with the knowledge. They may not have that particular title per se of being a rigging engineer, but I think it's pretty common to find someone that has the majority of the knowledge and experience required to serve in that position.
Sure. Okay. Well, I have a question here from John, and this is really a Mike question. I apologize, but Mike had to step out. We have a class here actually going on right now, and he had to go assist the instructors out there, but this would be right up his alley. John asked, how is the new lift planner law going to come into effect, and what will the responsibilities of a lift planner be? And John, what I'd like to tell you basically is that I assume you're talking about the ASME, the P30 lift planning standard, and what it basically is first of all, it's a standard. It is definitely not a regulation or law, so it's a best practice put forward by ASME, and I believe it is through public review, and they'll be publishing it after they submit changes and public review those changes. They'll probably publish it in quarter 1 or 2 of 2014. I think, just as an underestimate, it's kind of hoping and everyone's thinking it'll be January. But and then regarding the responsibilities, the document outlines kind of the roles and responsibilities of the team and the people involved that should be involved, and that what the regulation, or I'm sorry, what the standard says for the skills and the requirements, kind of, or this is what that person should look like, you know. So if you email me at Zack, Z-A-C-K, at ITI.com, John, I can probably shoot you some more information. But Matt, I don't know, have you been involved in the ASME P30 at this point, or do you have any other comments on that question?
I haven't been involved myself in the details of it, but that was my understanding of it also, is that it's really kind of a base document that doesn't have legal authority itself, but may be incorporated into law depending upon the particular jurisdiction. So that was my understanding of it.
Yeah, absolutely. Well, let's end on this last question, Matt. There's a kind of an anecdote about a gentleman who he's a contractor at actually marine and offshore, and he's basically talking about he voices a concern to the corporation regarding that there's little pre-planning, you know, and before lifting activities, and the comment back to him is usually that it's just the nature of our industry. I guess I want to frame it this way for you, Matt, for the listeners. How did FLUOR go from, I mean, maybe 20, 30 years ago to today? What did it look like to get the culture shift to the incredible amount of pre-planning? I mean, that's all we can really speak to, right? Or you can speak to. So how did FLUOR grow into the organization that it did culturally regarding planning lifts?
Well, my experience within FLUOR itself only goes back about 4 years, and within the industry about a little over 10 years. So my experience has always been with very large contractors, global contractors, and my understanding of it is that you know, we want to do the right thing. It's very important to our company that everyone goes home safely at the end of the day, and really the only way to support that is to pre-plan activities. So a lot of that is internally something that we've driven, and that does take time to develop that culture. Also, it's dictated in some cases by our clients. A lot of the projects that we work in really hazardous industries. We see a lot of leadership from our clients in the petrochemical industry, for example, being very particular about how we do lift planning and approval of lifts. So in a lot of cases, our clients have helped drive that culture and ensure that those are the sorts of things looked at and rewarded on projects. Sometimes you may even have a contract that is based upon your safety performance. So I think really the only way to address those things is through pre-planning, and I think that's the message a lot of the industry organizations are trying to push also. And it definitely can be a challenge. Things change often on construction projects, and it is a challenge to get everyone to look at these things ahead of time and to have the personnel in place and the resources to look at these things far enough in advance. My particular career, I've been sort of blessed to see most of my experience has been with organizations that see the value in pre-planning and spend the effort to do that up front. So I can't say I'm an expert on how to transform culture to get you there if you're not there already, but I can attest to the rewards that you can get by being in that sort of atmosphere and ensuring that things are looked at ahead of time.
Okay, well, I appreciate that. I realize your experience with them is limited. I know that the culture is definitely one of planning everything out due to the nature of just how big the corporation is, and everything you guys do is pretty specialized. So culture shift is difficult, but I don't know if anyone could speak to exactly how to handle that situation. So, but anyways, with that, we want to really respect everyone's time. And Matt, from ITI, we just really, really appreciate you and FLUOR's participation. It's been really interactive, and people have enjoyed it. I think I've been getting a lot of good feedback on the comments section. So thank you so much. And again, everyone, you can access this presentation on the website, and you'll be getting an email about that. And we just really appreciate you, Matt, for turning that over to the listeners as well. So thank you. I'll give you the last word.
Again, thank you, Zach. Personally, I really appreciate what you guys are doing to help support education in the industry, and again, helping drive that culture shift to make sure that we're doing things safely as an industry. That's really what it comes down to at the end of the day, is ensuring that our partners, our craftspeople, that everyone goes home safely at the end of the day, and doing these sorts of dramatic lifts and doing the everyday lifts and doing them safely. So I think it's great what you guys are doing to help support the education of the industry. So thank you.
Sure, we appreciate that. Thank you very much. And everyone, thank you again for attending, and have a great week and weekend in August. And we'll see you again soon. Appreciate it.